So in today's video, we will discuss complexity analysis in computer science and in data structures and algorithms specifically. So what is complexity analysis? Well, complexity analysis says how much space and how much time. So how much time t does it take to process n units of data? So if I have n units of data, how much space does it take up on my computer, and how much time is it going to take to process those n units of data? And we do this because we want to take programs and we want to optimize those programs in order to run as fast as they can, so that, for example, on your mobile device or on your computer, things can run faster and faster and faster, which is exactly what we want, with less space and time taken up. Okay, so we look at a concept called asymptotic complexity. Asymptotic complexity is an approximate measure of the algorithm's efficiency. Okay, so let's look at an example of this. So we're given n is our data size, so like we said, n units of data, and we're given a function f of n equals 2n squared plus 200n plus log base 10 of n plus 2000. And we say, okay, well, how can we analyze this in order to determine the complexity or the amount of time and space that this thing is going to take with n units of data? So n in this function is the amount of data. So if our amount of data is very, very small, then all of these factors with the value n are going to be very small, which means our f of n is effectively or more or less 2000, because those values are so small that the 2000 completely dominates in the function when n is small. When n is more or less equal to 10, then we see, okay, but 200 times 10 is 2000, and this is also 2000, so these two elements have the same contribution to f of n. It's just an observation we make. If n is more or less 100, well then 2 times 100 squared and 200 times 100 will give us also the same value. So they'll have the same contribution to our function. Then this is the part we're very interested in, is when n gets very, very large, when we have a lot of data, when we're processing a lot of stuff. So when n is much larger than 100, then we can see, well, this is not going to contribute that much. This is going to contribute less than this. If we square 100, and if we say 200 times 100, 2 times 100 squared is going to be a lot bigger, because it's 2 times 100 times 100. Or if it goes much bigger than 2 times, say if n is 200, 2 times 200 times 200, so 200 times 200 times 2, which is a very, very big number, which means this term, the 2n squared, is going to be the biggest contribution. It's going to have the biggest contribution to the function f of n, which means f of n is more or less equal to 2n squared. And then we define complexity with an O notation. So it has an O notation of n squared. So O of n squared is the complexity. We just notate it like that. Okay, then we're going to look at a second example. We're given the sort function. It's known as a selection sort. And you don't have to worry about how it actually works in terms of sorting, but we're asked what is the complexity of the given sorting algorithm.